All right, so guys, let me invite you to join me at the calendar. Again, we've been starting every day like this because we need to keep some things in mind. But guys, things have changed, and they may change again, so we need to talk. It really doesn't directly impact you guys because this is B-Day. But guys, even for your other classes, we should make sure you're all up to speed on this. So guys, you understand that tomorrow is no school. The state playoff game, we play at 11 o'clock. Guys, if you want to go, you've got to buy a ticket in advance. There are QR codes stuck on posters in the hallways. But guys, I also created a link on our website. So if you're having a hard time getting some people have said the QR codes don't scan right. So guys, this is a slam dunk. That'll take you there and you can get your tickets. But guys, there's no school on Thursday, tomorrow, which means we can't do the essentials test tomorrow, right? Because we're not going to be here. So guys, as a result, what we've done is we've moved the essentials test to Friday. So also remember that on Friday, guys, we've got our papers due. So understand, we're still going to flow and we're still going to move. So Thursday being interrupted does not change the fact that our papers are due on Friday. Guys, please, again, check the format for these papers. Cover sheet, 2 to 3 typewritten pages, everything's there in terms of the requirements. And then guys, your site, your sources page. So you're going to end up with between 4 or 5 pages for your paper. And guys, we're going to turn those in Friday morning. Now, the other thing you should know is this. If we win the game on Thursday, we then don't have school the next Friday. Again, this doesn't impact us at all, but it will impact your 8A classes. The game is again at 11. There were rumors that it was an evening game, but that's not the case. It's another 11 o'clock game, right, Cole? Do you know, Max? 11. So guys, we won't have school on Friday when we beat Springville. So guys, all of that to say, this is calendar stuff. Things to keep in mind right now are your paper and then also the essentials test if you're doing that. So guys, questions about this? Y'all good? Okay, now guys, this, and you're not going to know the difference, but I want to explain to you what we're doing today. So guys, normally the material that we are going to cover today, we do in one really big day. But that's not going to work because today's Wednesday and class is really short. So guys, we get to kind of take a deep breath a little bit. We get to slow down a little bit. And we're going to take 1 day's worth of material and spread it into 2 days. So guys, when you come into class on Friday, you're just going to gather up everything that you have in front of you right now, and we're just going to keep going. So you'll know when we're done today, because we're going to talk about extra credit projects. We'll talk more about that when we get there. But guys, there is an opportunity for extra credit, and we'll talk about that. And then guys, we'll wrap this up on Friday. So guys, with that said, here's what you need. Well, any questions there? You all good? Okay. So guys, you need your homework. And guys, let's go over this really briefly. We are not going to spend a ton of time and look at this homework assignment. As a matter of fact, guys, I'm going to give you all credit for doing it just for being here. Guys, if you didn't do it and that feels dishonest because you're going, wait, I didn't do the homework, I shouldn't get credit. Guys, you don't need to come to me and admit that you didn't do it. I'm going to give you credit for having done it. You don't have to come and tell me. But guys, what I do want to do is this. I need to gather you around this assignment. And guys, specifically, we need to look at these 2 pages. So guys, or at these 2 questions. So guys, take your homework assignment, flip it over. And guys, we've got to make absolutely sure that you're clear on these ideas. The ideas that you've got to be clear on are, first of all, the capacity of the energy levels. Guys, the capacity of the energy levels is given by the 2n squared rule that goes 2, 8, 18. Are you guys okay on that pattern? You okay? Okay. Then guys, the next thing that you need to be clear on is that energy levels are broken into sublevels. There are 4 sublevels. They are S, P, D, and F. And then the number of sublevels in an energy level is the number of the sublevel. So the first energy level can have 1. it's an S. The second two, S and P. The third is 3, SPD, and then SPDF on down from there. You guys, any questions on that? You guys, please.
We talked about G last
Yeah.
slightly, so
Yeah.
is that just, does it only go to G?
No. So it actually, let me get back here. It actually goes G, H, and I. So let's just talk about this really briefly. And then, so the idea is this. So we're going to find out, but maybe you're already connecting with this, that the S's are spherical. And then the P are dumbbell shapes. So these have shapes. And so originally, the way that we figured out their shapes was by solving Schrodinger's wave equations. These values, N and L and M and S, are actually variables in Schrodinger's wave equations. So we can plug in the numbers and figure out what the G and the H and the I orbitals look like. You can Google them. They're beautiful. But we've never found atoms complicated enough to need those spaces, so we don't have to talk about them.
So we don't use G at all, we just stop at F.
We stop at F. And it even is more interesting than that in terms of why, and you'll have some of the answers today, well, in just a minute. So guys, you good on that idea? One last idea, and it's this. So guys, the sublevels are then made of orbitals. The orbitals are in the cloud. And guys, the orbitals are the clouds. And then guys, the electrons in these orbitals are paired up. But what do you remember about their north poles? They're paired up oppositely. So one is spin up and one is spin down, meaning their north poles are opposite directions. You guys okay? All right, then you're going to like this. So guys, you can put your homework away. As I said, I'm going to give all of you credit for it. And now guys, all you need in front of you are the following things. You now need, let me put this away, let me grab this. Guys, you don't even need a periodic table today. We're not going to get to that until Friday. So guys, all you need today are the notes from last class period, and you need today's note sheet. And guys, you're going to like today. The patterns and the structures that we're going to talk about today are actually really fascinating. And it's going to get us to the extra credit assignment in just a couple minutes. So guys, again, you only need 2 papers in front of you, not a periodic table. Guys, all you need are these, and we're good to go. You ready? Okay, so guys, grab something that you can write with, and this is where we're going to start. Guys, looking at your notes sheet from last time. Guys, down at the bottom of this note sheet, we filled out this outline. What I want you to do is this. On your note sheet, circle everything that's in blue in my slides. Because guys, today we are going to take that information in the bottom of your notes and we're going to reorganize it in some really interesting ways. So guys, you need this information at ready recall. So guys, circle the word size. That is an important idea. You're circling the important ideas. And so guys, the first important idea is that the energy level number tells us the size of the cloud. Then guys, please circle the numbers 1 through 7. There are 7 cloud sizes. 1 is smallest, 7 is biggest. Then guys, after that, please circle 2n squared rule. How many electrons go in these levels, these clouds? And guys, the answer is the 2n squared rule. Now move down. So now we're going to go down to the sublevel number. Guys, what you need to do is circle the idea that the number of sublevels in an energy level is n. And then the names of the sublevels are S and P and D and F. Those are important. Then guys, do this. Moving down again to the orbital number, please circle the idea that an orbital holds 2 electrons. Then guys, moving down again, please circle up and down. The 2 electrons that are in an orbital have opposing spins It means that their north and south poles are opposite each other, and that creates a little bit of attraction that overcomes the repulsion between them. Okay, so guys, here's where we are. This is what we're going to do today. Guys, all of this information that you just circled in blue, guys, all of that information actually, and you don't know this yet, but it actually contains all of this. So guys, this stuff that we've been flirting with for the past 2 weeks is actually up there on the screen. We just have to help you organize this in such a way that this makes sense. So guys, things are about to change in just a moment. In just a moment, I am going to stop telling you things, and I'm going to start asking you questions. And guys, here's the deal. All of the answers to the questions are up here in blue. If you understand this, you know the answers to all of these questions. All we've got to do is then reorganize all this information, and guys, all of a sudden, this is going to make sense like you never thought possible. Before we do, though, there's one more thing that I need to share with you. Guys, grab your notes page. The one that we're doing today. So guys, we need to doctor this up a little bit, and then I need to explain to you what you're looking at, and then this will make sense. So guys, all the way down here in the bottom left-hand corner, please draw a half circle around the word nucleus. We understand that the nucleus is a sphere, not a circle, but you get the idea. Then guys, I don't know if you're familiar with this symbol, but let's do it and then we'll explain it. So guys, right above that, do you guys know, here, let me zoom into it so you can see it. On a graph, and again guys, lots of graphs on the ACT, right? You can never know too much about graphs. Guys, draw that symbol in blue right above nucleus. Do you know what it means, David? In math, it means approximation, but in graphing, it means something a little different. Do you guys know what it, do you know? Exactly. There's missing information. There's a gap. Is that, yeah. Guys, it means there's a gap. So let me explain to you the gap. So guys, remember the analogy. So if an atom, if the nucleus is the size of a marble, how big's the atom? Size of a football stadium. That's the gap. So guys, what we're talking about here is the distance between the 50-yard line and the cheap seats in Lavelle Edwards Stadium. So guys, the nucleus is not this close to the electrons. There's a huge gap like the size of a football stadium, but we just represent it with those squiggly guys, which in math does mean approximate, but here it means there's a gap or missing information. I just don't want you to think the electrons are this close to the nucleus. Then guys, do this. Let's write in what these mean. So N is the energy level, L is the sublevel, and M is the orbital. Energy level, sublevel, orbital. All right. Guys, we have now set the stage. We look back at last time's notes. We've gathered our arms around all the stuff that's circled in blue. We've got this all doctored up. Guys, there's only one more thing we need to do, and we're going to get to work, and I think you're really going to find this interesting. Guys, the last thing we need to talk about before I start just asking you questions is I need to explain to you what we are looking at as we're looking at this sheet of paper. So guys, are you familiar with the idea of a core sample? Do you know what a core sample is? Let me explain it to you. So guys, all of you, or well, not all of you, probably fewer of you now, but guys, when I bought my house in Linden, my home used to be in the middle of an apple orchard, and my backyard was full of apple trees. We're cutting them down over time because they're messy. But guys, when we first moved in, we were like, oh snap, we have 1 million apples, and what are we going to do with them? So we talked to our neighbor, who's very handy, and he's like, oh, why don't you just turn all of these things into applesauce. And we're like, okay, show us how. And so guys, I quickly became acquainted with what is called an apple corer. Have you ever seen one of these things? They are like wicked. It's like a metal tube with these teeth on the middle, and you take this tube and you stick the stem of the apple in it, and you shove this thing through the apple, and then you pull it back out, and now you can see through the apple because the core of the apple is now inside the tool. You know what I'm talking about? Guys, that's called an apple corer. But here's the deal. When you pull the core out of the apple corer, it's really like you're peering down inside of the apple. So guys, join me at the board and let me explain to you what I'm talking about. But we're not going to go all the way through. We're only going to go to the middle. So guys, if I could take this apple core and go halfway through and then lift this out of the apple, I can now tell you what is inside an apple. Because I need to grab my writing tools. Totally forgot. Just a second. So guys, I can now tell you what is inside of an apple. So looking at this apple, as I pull the core out of it, I can now tell you that an apple has a middle, that's where the seeds are, then there's a layer where the flesh starts, then there's a layer where the flesh ends, and then there's the skin, and then there's the stem. So guys, by taking the core out of the apple, I can then tell you what's inside the apple. That's called a core sample. Does that make sense? Okay. Now guys, let's do this. Let's take that idea and let's apply it to atoms. So guys, in the middle of an atom is the nucleus. Because of the work that we did last time, you now know that this is not the Bohr model. This is not electrons moving in orbits. This is a cloud that appears to be a solid because of probability and random motion. And guys, this is the first energy level, the first cloud. But then there's a second, and then there's a third. And these clouds stack one inside the other. But guys, here's the question. Just a second. What if I were to take a core sample of this? Well, guys, what would it look like? What would a core sample of this look like? Well, we would have the nucleus, right? We would have the nucleus at the bottom. And then we would have a line that is a boundary of the first energy level. We would have a line that is the boundary of the second energy level. We would have a line that is the boundary of the third energy level. You see what I'm saying? Guys, look down. That's what's on your paper. Do you get the idea? So guys, what we're looking at is literally this. So the idea is the nucleus is here, and then we've got the first level, the second level, the third level, the fourth level, and this is the core sample that would come out of the atom if we could drill into the atom and expose what's going on inside. Zach, go ahead.
This isn't really related to this, but when Bohr's experiments, didn't he kind of do the little flow experiment?
No, Rutherford did. Bohr worked with him, but Rutherford,
when he did the cold flow experiment, if the atom appears to be solid, even though this is not technically solid.
Yeah.
Did he shoot the atoms through?
That's a really interesting question. It's funny, that came up in every single class yesterday and the day before except for yours. It was interesting. Nobody asked, but we can talk about it quickly. This is the analogy that I gave people last time. Remember the fan that we got spinning, and we talked about the idea that the electrons, the fan blades still have space, but they don't behave that way because they're moving, and that's kind of like electrons. The analogy is this. I was shooting rubber bands at the fan and they bounced off, but imagine if I could shoot really, really small, really, really fast rubber bands. They would get through, right? Those are the alpha particles to the atom. The alpha particles are so small and so fast that many of them actually go through untouched. It's a little crazy, but there are actually these particles in the universe that are so small and so fast that they pass through the entire Earth and don't touch anything. There's actually 1 billion of them going through your body every second of every day. They come from the sun. They're called neutrinos. And they actually are so small and so fast that they pass through the entire earth and never hit a thing. So the way that we detect them is we go down inside of old coal mines and we set up these really big buckets of very pure water. And one time, like once in a day, one of these neutrinos will hit a water molecule and make it wiggle, and when it does, we can detect that. So they call them neutrino traps. So we've actually been able to detect these things, but again, it's not, so this gives us our reality, but there are definitely small things that get through. Okay, you guys good on this idea of the core sample? You're good? All right, guys. This is all about to change. And it goes like this. Guys, I am now just going to start asking you questions. And guys, you know the answers to these questions. And as we answer these questions, we are now going to pull together the wave model of the atom. So guys, first of all what do the rungs on this ladder represent? The levels, the energy levels, right? How many of them can there be? Look at your notes. 7, 1 through 7, right? Guys, we are going to number them 1, 2, 3, and 4. We are not going to go all the way to 7 simply because we do not have enough space. But guys, if you allow your eye to fall right here, go ... up to 7, indicating that this could go up to 7. Now guys, this, again, another question, right? Not teaching you anything, another question. So guys, let's go down to energy level 1. How many electrons go in energy level 1? 2. How do you know? No. What's the equation? 2n squared rule. Guys, 2 electrons go in the first energy level. That's the 2n squared rule. So the lines that we're writing on the numbers we're writing on the lines are the numbers of electrons. So guys, applying the 2n squared rule, how many electrons go in energy level 2? Write it down. How many electrons go in energy level 3? Squared is 18. Energy level 4, 32. We're going to stop there. Again, guys, just asking you questions. So now here's what we're going to do. We have fleshed out the energy level space as much as we're going to. We're now going to move to the sub-level space. So guys, let's review. How many sub-levels can be in an energy level? Look at your notes. How many sub-levels can be in an energy level? N. Right? Watch my fingers, guys. Again, you should know this. First energy level, 1 sub-level. What is it? S. Second, 2, S&P, 3, SPD, 4, SPDF. Good? Okay. So guys, here's how we're going to represent that. Come down here to energy level 1 and draw an arrow. That arrow is taking you over to the sub-level zone. Then guys, underneath the sub-level zone, please draw a dashed line. So we are now moving from energy levels down into sub-levels. So guys, that line right there represents the 1 sub-level in the first energy level, but what is it, SPD or F? It's S, right? But hold on, we're going to label it not just S, we're going to call it the 1S because it's in the first energy level. Now guys, this, again, check your notes if you need to. Guys, we are now going to talk about orbitals. The orbitals are the clouds, okay? Now, how many electrons can go in an orbital? There can be 2 electrons in an orbital. So guys, let's then talk about how this fits together. So here's the idea, and I know this is low on the screen and maybe hard to see, move if you need, but guys, this is the idea, ready? So coming back to sublevels, first energy level, 1 sublevel. That 1 sublevel is an S sublevel. Now guys, I need to ask you a logical question. If the first energy level only has 1 sublevel, and if the first energy level has 2 electrons, how many electrons have to be in this sublevel if there's no other sublevels for them to be in? How many electrons have got to be here? 2, both of them. There's nowhere else for them to be. So the first energy level only has one sublevel. If it's an S, it's got 2 electrons. There's nowhere else for them to be, so they got to be there. Because that logic might have been a little weird. If that didn't make sense, it will when we do energy level 2. But let's keep going. Now, guys, let's go to orbitals. So, guys, now we need to know energy levels broken into sublevels, sublevels broken into orbitals. How many orbitals will it take to house these 2 electrons? How many electrons go in an orbital? Paired up, right? We said that a minute ago. 2 electrons in an orbital. So, guys, if we need enough room for 2 electrons, we only need 1 orbital. Guys, don't draw it yet, but this is what it looks like. Let me explain to you how we're going to draw this. So, guys, this looks super familiar. You've seen this before. Let me zoom into it for you. But, guys, this is super familiar. What do the dots represent? Possibilities of where the electrons are. But guys, do you know what this means? What does it mean that we have an up and down, a left and right, and a diagonal axis on this graph? It means it's 3-dimensional. So guys, it's not flat, it's spherical. And so guys, what you're going to draw is simply this. Draw the 3-dimensional, I do this in your notes, down to there. Guys, and let me zoom out so you can see. You literally want to draw it this small. So guys, like this, draw yourself the 3 axes and then draw a circle over that, indicating that the 1s orbital is actually spherical. What's in the middle of this? The nucleus. But this is the 1s orbital. Some of you are going, wait, I've seen that before. Oh yeah. You guys all caught up? I don't want to go too fast, but you okay? You're good? Okay. So now, guys, let's do this. Let's do this and clean this up. And now, guys, we're going to jump up to the 2nd energy level. So what we're going to do now is we are going to draw ourselves another right-pointing arrow. Now, guys, please don't write anything until we talk. So again, energy levels are broken into sublevels. Guys, how many sublevels are in the 2nd energy level? 2, and what are they? S and P. But wait, guys, draw them like this. Here's what you're going to do. Allow your eye to travel across, and then when you draw them, you're going to do down a little and up a little, and you're going to link them together like this. So guys, the bottom line represents the 2s, and the top line represents the 2p. Now guys, the logic gets even better. Check this out. We established that there's 2 electrons in the 1s because there's nowhere else for them to be. Well, guys, it turns out that that pattern continues. There are also 2 electrons in the 2s. I have a question for you. How many electrons then have got to be in the 2p? Gracie, talk to us about 6. Was that you? You're right. Talk to us. How did you come up with that? Beautiful. Guys, do you see it? If there are 8 total electrons, and if 2 of them are in the S, how many have got to be in the P for a total of 8? 6. So guys, there are 6 electrons in the P sublevel. So now, guys, let's go to orbitals. Ready? How many electrons go in an orbital? 2. Are they different? Spins. Let's go. So guys, how many orbitals do we need to hold these 2 electrons? Only 1, and it looks like this. Draw it. But guys, before you draw it, let's talk. How is it different from the 1s? How's this different? It's bigger. It's in the 2nd energy level. It's bigger. So when you draw the 2s orbital, you're still going to do the same thing. You're going to go up and down, left and right, diagonal, but you're going to draw a bigger circle so that you know that the 2s is bigger than the 1s. Go ahead. We're going to draw it now. It's coming. You guys okay? I don't want to rush you. We're doing good on time. You're good? All right, now guys, check the, we're just doing subtraction and division, right? And we're figuring out the Schrodinger wave equation. This is crazy. But guys, check this out. So it took one orbital to hold 2 electrons. So how many orbitals does it take to hold 6 electrons? 3. And guess what, guys? Our simple math is telling us that there should be 3 p orbitals. And guess what? There are 3 p orbitals, and they look like this. So guys, hold on. This is what you're going to draw. You're going to draw one that is up and down, one that is left and right, and then one that is diagonal. Those are the 3 p orbitals. Sorry guys, I'm so in the way. So guys, we give these p orbitals a name. We call them dumbbell shaped. I know they look like figure 8s, but back in the 1940s, they chose to call them dumbbells, and we will too. So guys, once you've got this on paper, there's one other thing you need to understand about these. They are actually not separated like this. Guys, this is kind of a challenge, but pray for me. So one of them goes up and down, one of them goes left and right, one of them goes in and out. But guys, when they are centered, oh shoot, when they are centered around the same nucleus, they orient like this. What are those angles between these? They're 90-degree, good. They're 90-degree angles, and guys, why would that be the case? Guys, what's inside of these clouds? Electrons, and they're trying to get away from each other. So guys, these things orient themselves 90 degrees to each other because of repulsion. David, you're right on it, buddy. All right. So guys, time for a big, deep breath. You ready? Here's what we've now established. Let's review. The first energy level contains one sublevel. It is an S sublevel, and those 2 electrons in the S sublevel are in a small sphere centered on the nucleus. The second energy level contains 2 sublevels. 2 of those electrons are in a bigger sphere centered on the nucleus, and then these 6 electrons are in dumbbell-shaped orbitals that actually are about the same size as the 2s. A little bit bigger, not quite, a little bigger, but about the same size. So we have a small sphere, a bigger sphere, and then 3 bigger figure 8 dumbbell-shaped spaces. Guys, the question is this. What does this look like when it all comes together? Well, guys, first of all, this. What element are we talking about? Well, we've got 2 electrons here, and we've got 8 electrons there for a total of 10. Guys, I know you don't have your periodic table, so let me just tell you, element 10 is neon. So guys, if we could bring this all together visually, what we would be looking at is what a neon atom actually looks like. So guys, let me introduce you to a neon atom. Do you see it? Guys, this is what a neon atom actually looks like. So let's make sure you're seeing what you should be seeing. So guys, talk to me about this small spherical space right there. What is that? The 1s orbital. And guys, talk to me about this bigger spherical space right there. What's that? That's the 2s orbital. And then talk to me about these dumbbell-shaped orbitals that are a little bit bigger than the 2s orbital. What are those 3 dudes? Those are the 2p orbitals. And so guys, we've got the 1s, and the 2s, and then the 3 2p's, and all of those together give us space for 10 electrons. And guys, that's a neon atom. That's what neon actually looks like, yeah.
Why are they yellow?
Yeah, great. And so here's the thing. I lifted this out of an old textbook, and they tried to stylize it by showing like the tracks of the electrons and things like that, which frankly I really hate because that looks like Bohr model tracking electrons. Really, they should set this in motion, and the electron should be jumping in and out of existence and move. It's just a style. It's an artistic thing. So, guys, do you see the 1s and the 2s and the 2p and then how they all stack together? But guys, that's all of this. That's all of this. We've got the 1s and the 2s and the 2p and the 1s and the 2s and the 2p and the 1s and the 2. Guys, however, or even as we stack all of them together into these crazy, amazing structures, guys, this is what we've been moving towards for the last 2 weeks, is getting this stuff to make organizational sense to us based on this 1s and then the 2s and the 2p and their shapes and their sizes. And guys, this is what these atoms actually look like. Questions or things you need to talk about? Okay, now guys, watch closely. I'm going to go back to our notes page. See if you can see what changes. Do you see it? What's different? What's different? Say it again. The orbitals are gone, you guys. And we replaced them with boxes. You don't need to do this in your notes, but guys, this is actually how we're going to draw the orbitals. We choose boxes because boxes are not like any of the orbitals, so we're not confused. What do the arrows represent? The electrons. What does it mean that one is pointing up and the other is pointing down? The opposite spins. So guys, we are not going to ever draw the orbitals. What we are going to do is draw boxes to represent the orbitals, but we understand that this is a small sphere, this is a bigger sphere, and then these are the 3 dumbbell shapes. All right, guys, let's keep climbing up the ladder. Join me now at the 3rd energy level. Guys, again, back to the questions. 3rd energy level, how many sublevels? 3, what are they? S, P, D. Now guys, watch. When you do this, be careful. We're going to draw an arrow. Oh shoot. We are going to draw an arrow that will move us over to... Oh, I'm drawing dots in white of all things. So guys, we're going to draw an arrow that moves us over. But now guys, we've got to do the S, the P, the D. Don't draw, just watch. We're going to go like, my poor screen. Guys, we're going to go like this. We are going to go like so. So guys, here's what you're going to do. You're going to move over, you're going to go down, then hold on, you're going to go slightly up. But guys, this is the important part. Draw this line right below the 4th level. Go ahead and do that now. And then label them S and P and then D in the 3rd energy level. Okay, so now guys, we're back to logic and we're back to math. How many electrons go in the S? 2. How many in the P? 6. Now can you answer how many have to be in the D given Gracie's logic? 10. Hey, 10. Because we've got 18 minus 6 minus 2. That gives us 10. Now guys, let's do this. Let's move into orbitals. How many orbitals does it take to house these 2 electrons? 1. What's its shape? Big sphere. Draw a box with 2 arrows. Now guys, how many orbitals does it take to house these 6 electrons? 3 bigger dumbbell shapes. Draw 3 boxes and 6 arrows. But guys, hold on a second. Let me show you how to do this easier. Here's what you do. Guys, in order to draw this, what you want to do is draw a rectangle and then break it into 3 parts by drawing 2 lines. Then guys, when you draw your arrows, draw check marks. Up and down, up and down, up and down. It makes it a lot easier. Then guys, let's check out the D sublevel. Ready? How many orbitals is it going to take to house 10 electrons? 5. And guess what, guys? There are 5 d orbitals, and they look like this. These are the clover leaves that we've been talking about for the last couple days. But we are not going to draw clover leaves. We are going to draw 5 boxes and 10 arrows. So again, guys, longer rectangle, 4 vertical lines. Draw the arrows inside. Guys doing good? It was funny, the very first time I ever figured out how to teach this material like this, it was actually a week later in the year. It was the week before Thanksgiving, and my brother was in town. He's a neurologist who has a degree in chemistry. And he's like, hey, brother, can I come watch you teach? I'm like, yeah, come on. And he was sitting in my class. Remember, he's got a degree in chemistry. And he watched me teach this to my students, and he was like, you got to be stinking kidding me. I'm like, I know, right? Like, you learn this stuff in college and it seems impossible and weird and distant. And he was like, I've never thought of it that way. And I'm like, I know, me neither. It's really cool. Anyway, all right, let's keep going. So, guys, you ready to do energy level 4? Coming back to the questions. Energy level 4. How many sublevels in energy level 4? S, P, D, F. Guys, you're not going to like this. Watch before you draw. You are going to draw yourself an arrow. Go ahead and do that. But guys, this is where this gets crazy. Watch. Ready, S, P, D, F? They overlap. So guys, when you move down to draw the 4S, it has got to be between the 3P and the 3D. It's actually, Gracie, it's not quite drawn, well, it's kind of. It's closer to the D than it is to the P. Then guys, moving up from there, we've got the 4S, the 4P, the 4D, and then the 4F. So now, guys, same logic. Let's draw in the electrons. 2 in the S, 6 in the P. We established logically that there are 10 in the D. Can you do that math? How many in the F? There's 14. So guys, same logic now. What does the 4s orbital look like? Huge sphere. Draw a box with 2 arrows. What do the 4p orbitals look like? Huge dumbbells. Draw 3 boxes and 6 arrows. By the way, guys, Friday is the last day you're going to have to draw arrows. You're going to get so sick of drawing arrows, it does go away. Then, guys, the D5 orbitals, what do they look like? Huge clover leaves. We're going to draw 5 boxes and 10 arrows. And what's that? You can, but realize that when we start using this predictively on Friday, that's going to back up on you. But you understand the logic and you can always adjust. A good note-taking strategy. All right, you guys ready to wrap this up? Darn you. 7. I love that you know the patterns. Guys, this is all about patterns. We live in a world that is based on patterns. So guys, how many orbitals does it take to house 14 electrons? But here's the thing that's cool. We know what they look like. Guys, they actually look like this. And I find this amazing. that we have electrons everywhere in this world, in our bodies, in this universe, that are built on shapes that look more like flowers than they do like chemicals. It's kind of cool. But guys, what we're going to do is this. We're going to draw boxes and we're going to draw arrows. Well, but Zach, don't take that for granted. Go take a college chemistry class and look at how they teach this to you, and then remember this moment. Because the only reason you were, forgive, this sounds boastful, but the only reason you were able to do that is because I'm good at this. Seriously. And again, it sounds arrogant, but it's not. You can make this so ridiculously difficult that I've seen classmates of mine in college drop out of chemistry because they couldn't figure this out. That's why my brother was going, oh snap, I've never thought of it this way. And frankly, that's what makes people really good high school teachers, is because they can take really difficult things and make them accessible. University professors most of the time don't care, but yeah, it makes it interesting. So guys, we have just a couple more minutes together and then you're going to work on your homework. Guys, it goes like this. This interesting pattern that many of you are finding accessible, just like Zach. But guys, again, understand this is crazy. When you really dig in, it's amazing. Guys, this pattern persists. The 5th and the 6th and the 7th energy levels with the overlaps and the orbitals and the structures just keep going. But guys, we're going to stop here. But this then is where we're going to talk about extra credit. So guys, what you see on the board, what you see in your notes, is the organizational structure of the first 4 energy levels on our periodic table of elements. And guys, again, the order goes like this. 1s, small sphere. 2s, bigger sphere. 2p, dumbbell shapes. But guys, this is important. Dumbbell shapes that are only slightly bigger than the 2p. Then guys, what's that guy look like? Big sphere. Then guys, what does this look like? Bigger dumbbells that are approximately the same size as this. Then guys, what does this look like? Approximately the same size as these, but clover leaves. Do you get the idea? Guys, that is your extra credit assignment. To take this idea of small sphere, bigger sphere, dumbbells that are about the same size, then bigger sphere, bigger dumbbells, bigger clover leaves, and represent through the 4th energy level, 1s, 2s, 2p, 3s, 3p, 3d, 4, on through. Now guys, here's the assignment. They have to be correct in terms of size, they have to be correct in terms of shape, and they need to be correct in terms of the numbers of orbitals. Now guys, with that in mind, I love that you're all not listening or paying attention to me. You're looking at the wall. Guys, people have come up with absolutely brilliant ways to do this. Understand that this is the Hall of Fame. The vast majority of these projects just get graded and thrown in the bin. But guys, these are the best of the best. And I love the creativity of these. We went 1, 2, 3, 4, SPDF, and you can see the S's get bigger. You can see the P's about the same size as the S's. The D's about the same size as the P's. The F's, which is down here in a cycling trophy, the same size. Love that. Guys, some people have done this with modeling clay, done it on paper. This almost burned the school down, but you get the idea. Some of my very, very favorites. Oh. Lexi. Huh? Lexi did hers. Is she like 25?
That's Paige.
Oh, all right. So, guys, Lexi, I love this. She just did this with sandwich bags. There's the 1S. There's the 2S and the 2P. And the thing that's really cool about this is it becomes like a shadow box. And you can look down into it and see the depth Another person did this on a Cricut. This was really interesting. I don't know if you know the paper cutters, the computer, they're called a Cricut. So here we have the 1s, and then the 2s, and then the 2p's, and it's like the shadows of the orbitals. And again, you can look down into the brilliant stuff. So guys, here then is the assignment. This is due on the day of the test. Again, you are going to create a representation of the orbitals, 1s, 2s, 2p, 3 on through. And guys, they need to be correct in terms of size, shape, and number. Now, you're welcome, just like the last extra credit assignment, to work with a partner. That's fine. It could be somebody from Mrs. Call's class. You're not going to split credit. But guys, here's the deal. We haven't yet figured out the number of points associated with this, but from experience, I could get eyewitness testimonials from first quarter that many people, even in this class, were like going, thank goodness for extra credit. So guys, the assignment then gets one last detail. In order to get full credit on this assignment, it can't be a replication of one of these. So you don't get to look at this and go, oh, clay, that's really interesting. I'm going to go build something out of clay. And understand the penalty for not being original is not huge. Last year it was 1 point out of 15. I don't know that that'll be the case. It'll be small. I don't know how many total points, but it'll be small. But if you want full credit, it has to be unlike any of these. Because the reason that we do that is it kind of pushes the boundary. Like last year, it led somebody, it was actually, who was that? Oh, Ellery, Killian, to do this. And guys, it provides really neat new ways of thinking about this stuff. So again, it's due the day of the test, and we'll just collect them up from you. Ms. Call and I will grade them, yeah? So I'm hesitating a little bit. Ours is fixed. So guys, the test is going to be next Thursday. A day is going to get weird because we may not, their test is supposed to be Friday, which could be football, but ours for sure will be next Thursday. So guys, other questions or thoughts about this? Okay, so guys, this then is where we're at. Grab your homework packets. You need one. Guys, if you need one, you can grab one in just a moment. Yep. We are now on homework assignment number 2. So guys, here's what we're going to do. Looking at homework assignment number 2, the top of this should look really familiar, right? What you're doing is replicating your notes into the homework. Guys, I know that that's redundant, but from experience, we know that having this experience is helpful. Then, guys, question number 2, it says write the order of orbital filling. Do not do that. We'll do that next time. Then, guys, down below that, it says what is the shape of the following and how many of them are there in each sublevel. Guys, do that. Then do number 3 at the bottom, how do the p orbitals overlap? So on the first page, don't do question number 2. There is a back to this. We're not going to touch it. That'll be your homework on Friday. Again, guys, we're splitting the day. So you just need to do the first one, the third one, and the fourth one. We will look at that on Friday, and then we'll go on from there. So guys, thanks. Interesting stuff, right? I think so. Good stuff. So if you need help on the extra credit, let me know. And again, guys, we'll turn those in on Thursday. Please remember your papers are due on Friday. And guys, understand Thursday is going to be a messy day. If you're thinking you're going to spend Thursday writing your paper, most of you are going to be in Salt Lake for most of the day. So plan accordingly. And we've got about 7 or 8 minutes left.